Well, hello there, my little angels. Welcome to 5.5. We're going to talk about the discriminant, the nature of the roots, and the sum and the product of the roots. Now, for homework, after your quiz, you were to complete the worksheet that discussed the discriminant and the nature of the roots. So we are going to skip over this table because we will have already talked about that. All right, so let's move on to the sum and the product of the roots. You do not actually have to solve a quadratic equation in order to find the sum or the product of the roots. There is actually a formula that's going to help us when given a quadratic equation. We can use these formulas to find the sum, and we can use a different formula to find the product. So if you take a look at the first question, it says find the roots of the given quadratic equation using a method of your choice. I'm going to go ahead and factor this. So this would factor as x plus 5 and x minus 2, making my solutions negative 5 and positive 2. Now, if I was to find the sum of the roots, if I was to add these two together, negative 5 plus 2 would give me negative 3. And if I was to find the product, multiply the two of them together, negative 5 times 2 is equal to negative 10. So the sum of the roots is negative 3, and the product of the roots is negative 10. Now, the quadratic equation is ax squared plus bx plus c. So if it is in standard form of ax squared plus bx plus c, then we have two little formulas that will help us find the sum and the product of the roots, rather than actually solving it via factoring, completing the square or the quadratic formula, in order to find the sum and the roots. So if I want to find the sum of the roots, the formula is negative b over a. Okay, so that would just be the opposite of your b value divided by your a value. And the product is c over a. Okay, and that's all there is to it, to the sum and the product of the roots. All right, so let's take a look and see how this works. So first things first, let's get this in standard form. So this is going to be x squared plus 6x minus 16 equals 0. So I'm going to go ahead and identify a, b, and c. So a is 1, coefficient of x squared. B is 6, coefficient of x. And c is negative 16. So if I want to find the sum, which is negative b over a, I'm going to say it is negative 6 over 1 or negative 6. So there's my sum. And if I want to find the product, the formula for the product of my roots is c over a. So that in case would be negative 16 over 1 or just negative 16. So the sum of my roots is negative 6. So if I added my two roots together, whatever they may be, this doesn't tell me what they actually are, just tells me what the sum of them are and what the product of them are. Okay, so if I added them together, I'd get negative 6, and if I multiplied them together, I'd get negative 16. Alright, next one, put it in standard form. 3x squared plus 9x minus 2 is equal to 0. Identify that a, b, and c. So a is 3. B is 9, and C is negative 2. So the sum of my roots, not having any idea what they are. Oh, hold on, guys. I gotta go get my power cord. Okay, phew. Found my power cord. We're all good. Alright, back to the sum and the product of the roots. Okay, sum, negative b over a. So in this case, my b value is 9, so it's going to be negative 9 over my a value, which is 3. So that's going to reduce to negative 3. So the sum of my unknown roots is negative 3. And my product, we have c over a. So that's going to be negative 2 over 3. So the product of my unknown roots happens to be negative 2/3. Okay, just as we can take the equation and find the sum and the product, we can also take the sum and the product and write the equation. So in this case, in number 3, it says write a quadratic equation whose roots have the indicated sum and product. So remember, our formulas for the sum was negative b over a, and the product was c over a. So if I just write this as negative b over a equals 4 over 1. if the way I'm looking at this, what I'm going to do is I'm going to match up my B and I'm going to match up my A. So if negative B is equal to 4, then my B value would be negative 4. And if I match up my A value, it looks like I got an A value of 1. So I'm just going to hang on to those for a second, because in order to write something in standard form, I need A, B, and C. So let's move over here. I have C over A is equal to 3 over 1. So again, we have that common A value of 1, so that's good. And it looks like we have a C value of 3. So now I have A, B, and C. I'm just going to go ahead and write this in standard form. So I'm going to say 0 equals, we have 1 x squared. And our B value is negative 4, so minus 4x. And our C value is 3, so plus 3. And that's the equation of the formula, or for the quadratic, that has a sum of the roots are 4 and the product is 3. Alright, so now let's take a look at the next one. The next one's a little bit trickier. We have negative B over A is equal to negative 1 over 3, and C over A is equal to 2 over 1. Now, if you'll notice, what's different in this one is that your A value is 3 in the sum, but it's 1 in your product. So what I'm going to do is I'm going to get it so I have a common A value. So I'm just going to multiply the product over here by 3. So this now becomes 6 over 3. So what I did was I created the fact that my A value is now going to be 3. So we've established that A is 3. Alright, if negative B is equal to negative 1, then B is just equal to 1. And if I come over here, remember I multiplied by 3, so my C value is now 6. So we say 0 equals, our A value is 3x squared plus 1x plus 6. And there's the quadratic, whose sum is negative 1/3 and product is 2. Okay. Alright, next thing that we're going to do is I'm going to give you the roots, and we're going to work on writing the equation. So we're kind of going to work backwards. I'm giving you the answers this time, and you're going to give me the question. So there's a couple different ways that you can do this. You can either find the sum and the product of your roots and then write the equation, or you can actually put them as factors and work backwards and multiply them together. So I'll show you 2 different ways here. The first way I'm going to do it is I'm going to find the sum and the product. So if I was to find the sum, I would take radical 3 and I would add to it negative radical 3. Well, guess what, folks? That's going to be equal to, take a wild guess. Oh, you're right. Good guessing. 0. Okay? And now the product, if I take radical 3 and I multiply it by negative radical 3, I'm going to end up with, good, you guys remembered your rules from last time. We just end up with a negative 3. So our sum is 0 and our product is negative 3. So if I do negative B over A, if I'm going to get 0 for an answer, then my B value must be 0. And if I'm going to do C over A for my product, that means I'm just going to get negative 3 over 1. So it's looking like an A value of 1, a B value of 0, and a C value of negative 3. So that would just look like 0 equals x squared, oh, no B value because that's 0, minus 3. So that's what it would look like. Okay, now, if you wanted to do it as factors. So if I ended up with the square root of 3 for an answer, that means that one of my factors must have been x minus radical 3. And if I ended up with negative radical 3 for an answer, one of my factors must have been x plus radical 3. So basically what I did there was I just changed the signs from the beginning. Now you're going to double distribute this. You're going to multiply everything out. So we got x squared, then you'd get plus x times radical 3 minus x times radical 3 minus 3. And if you notice what happens, these two middle terms here, they cancel each other out. And you're left with x squared minus 3. We turn it into a quadratic equation by setting it equal to 0. Okay, so it's two different ways to do it. Find the product and the sum, find your a, b, and c values, or write them as factors and multiply them out. So on part B here, if you want to find the sum and the product, one of the things that you need to remember about finding the sum using fractions is that you need a, anytime you add or subtract fractions, yes, common denominator, good. So we're going to take 2/3 and we're going to add a negative 1/4. So common denominator between 3 and 4. Nice, 12. Okay, so we'll multiply this by 4 over 4, and this one by 3 over 3. So I now have nice new fractions of 8/12, and we're pretty sophisticated math people here, so instead of plus a negative, we're going to do minus 3/12. Okay, so 8/12 minus 3/12 is going to land me at 5/12. So there's my sum and my product. Let's multiply these two together here. So 2/3 times a negative 1/4. So remember, when you multiply fractions, you're going to multiply straight across. So this is going to give me negative 2/12. Oh, this is going to work out nice. So remember, your sum gave you the negative b over a. So that would be 5 over 12. So if negative b equals 5, that means b is going to be negative 5. We got a nice a value of 12. The reason I'm keeping 12, oh yes, over here, product, see that, a is 12. And c is negative 2. So that's going to work out nicely. So let's go ahead and write our equation. We got 0 equals, a value is 12, so we got 12x squared. B value is negative 5x. And wrap it up with a c value of negative 2. So, there you have it, folks. 12x squared minus 5x minus 2 equals 0. Ooh, imaginary numbers. Nice. Let's go ahead and add these and multiply these things together. So, sum 1 plus 4i plus 1 minus 4i. Well, guess what's going to happen to those 4i's when you add them together? You're right. They're going to cancel. And the sum of those two numbers is 2. I know. Weird, isn't it? You add two imaginary numbers together and you end up with a real number. Alright, now we are going to multiply these out. So, reaching back to last unit, if I have 1 plus 4i and 1 minus 4i, what do we call the relationship between those two binomials? Starts with a C, rhymes with conjugate. Oh yes, that's right, conjugate. Okay, so these two are conjugates. So we only have to multiply the first terms and the last terms. So we get 1 minus 16i squared. Alright, folks, last unit we learned that I squared was equal to negative 1. So this is really going to be 1 minus 16 times negative 1. So we got 1 plus 16 here. That's positive 16. So that's going to give us 17 for the product. Now, these are both integer values. They are not fractions. So we can assume that our a value is 1. If the sum is a positive 2, that means your b value is going to end up being negative 2. And we have a product or c value of 17. So let's go ahead and write this equation. We got 0 equals x squared minus 2x plus 17. Beautiful. Okay. And D. Oh look, we have another set of conjugate pairs here. So these sum, when I add them together, the radical 7s would cancel, so our sum is 2. And let's take a look at the product. Since they are conjugates, we only have to multiply the first terms and the last term, so we're looking at 1 minus 7, which is going to give us a negative 6. Nice integer values. We can assume that the a value is 1. The b value, if our sum is 2, that means our b value is negative 2, and we have a c value of negative 6. So we get 0 equals x squared minus 2x minus 6. Okay? Alright. On this next part here, if you'll notice, we are missing a little piece of information here. So it says find the missing root and the value of c if one of the roots is given. So 5 is one of our roots. And we are out to find the other ones. Well, we know that if I want to find the sum, I would do negative b over a. So in this case, that would be negative 15 over 1. So I know that the sum of my two values has to add up to negative 15. So that means 5 plus some number, we'll call it n, has to add up to a negative 15. So what would your missing n value be here? So we would subtract 5 from both sides. So it looks like our missing value here would be negative 20. So our second root we are looking at is negative 20. Now that's not your c value, okay? What that is that's your other solution. So your one root is negative 20, your other root is 5. So in order to find your c value, we're looking for the actual product, because remember the product was c over a. So we're looking for that product. So you're going to take negative 20 and you're going to multiply it by 5, and what do you get for a value? Good, negative 100. So that means our c value, our product here, was negative 100, and because our a value is 1, we are good to go with that one. Okay, so when you're missing one of your values in your equation, and they give you one of the solutions, you have to use your knowledge of the sum and or the product to help you figure out that missing information. Okay, so in this last one here, we're missing the b value. So here's one of our solutions, is negative 1. So let's go ahead and see here our product, remember, is c over a. So that happens to be negative 5 over negative 7. So the product is really just 5 over 7. Well, if one of our roots is negative 1, that means negative 1 times our other root, we can call it n, has to equal 5 over 7. So guess what n would be? Oh yeah, you guessed it, negative 5 over 7. Okay, so that's our other root. That's our missing root. So this is our second root. So our two solutions are negative 1 and negative 5 over 7. Okay, now we need to find the missing b value. So b has to deal with the sum. So remember, the sum is negative b over a. So in this case, you're going to add your two values together. So negative 1 plus a negative 5/7. Remember, you can't add fractions unless they have a common denominator. So let's make this one negative 7 over 7 minus 5 over 7. Alright, negative 7/7 minus 5/7, folks, would be, good, negative 12/7. Alright, so it looks like we have here negative 12/7. Now we know that the a value is negative 7, so I'm going to scoot my negative down to my denominator because I know that my a value is negative 7. That means that negative b is equal to 12, so therefore b would be equal to negative 12. So that missing value is going to be negative 12. Okay? And there's a couple different ways that you can check these on your calculators too. You can graph them on your calculator and then find your intersect function, find your solution. So there's a couple different ways you can check them on your calculators. Alright, don't forget, you were supposed to do the nature of your roots and your discriminant as your homework after your quiz, so that should have already been done. We will discuss more product and sum in class, and I look forward to seeing you guys in class.